Okay, you guys can hear me. So do a quick sound check. Good to go. All right, so let's go ahead and get started. My name is oops, got someone who wants to be admitted. My name is Jeffrey Banks. I am the new tutorials chair for the Washington Metropolitan Area chapter of INCOSE. Happy New Year. And look forward to working in this role and bringing some very talented folks to share what they know about a myriad of system engineering um, tools and subject matter areas to you guys. Um, this is our first tutorial of this calendar year, and we have Dr. Stephen Dam, who's going to present on his product called Innoslate. Um, but before he gets started, I want to do a brief intro. Dr. Steve Stam is the president and founder of the Systems and Proposal Engineering Company, better known as Spec Innovations. He has been involved with structural analysis, software development, and systems engineering for over 45 years. He has authored four systems engineering based books, including the most recent one, Real MBSC, Model-Based System Engineering Using Lifecycle Modeling Language or LML in Innoslate. Dr. Steve Dim has a BS, excuse me, BS and PhD in physics. He's also an NCOSE certified ESEP, an AI Associate Fellow, and member of the System Engineering Technical Committee and Digital Engineering Integration Committee. Dr. Dam is also currently the president-elect of the Lifecycle Modeling Organization and a longtime member of the Lifecycle Modeling Organization Steering Committee. So without further ado, I would like to pass the mic over to Stephen. Welcome, Stephen.
Great, thanks. And I'm just going to say hi. I'm coming from home. I just got back from a vacation in Hawaii, and it was delayed coming home because the flights had been canceled. So it was quite a day yesterday. Finally getting back here early this morning. So anyway, so I'm excited about presenting this, and hopefully people can see it and ask questions. I'll leave plenty of time for questions and things. So let me share my screen. I've got a few kind of slides to go through. I guess, can you see my screen okay?
Yeah, it's a little tiny. At least we're looking at I think your file list of files in your
Oh,
directory.
did the wrong one. Let's see. It picked the wrong one. Let's try again. Desktop 2. Okay. Is that working now? It should be a full screen.
Yep. Yep, looks good.
Oh, perfect. Okay. And I went off video again because bandwidth issues being at home. Um,
Mhm.
anyway, so thank you all for pretending. I don't know how many of you are familiar with InnoSlate. Um, Let me give you a little of the history behind the tool and a little bit of the big picture, and then we can dig into it as deep as anybody wants to go. So our yes, okay. I'm happy with it being recorded. So I started the company back in 1993, and I'd worked for a variety of companies over the years. Started my career at Los Alamos National Laboratory, doing nuclear weapons design work and counterterrorism, and got involved after that working. I was project lead there, and I became a project engineer at TRW and then again at Rockwell. Got into a variety of different projects there, particularly back in those days. SDI was the big thing, and so I got very involved in those efforts, and then went to SAIC. And in that process, particularly Rockwell, I got very involved with proposal writing and ended up with my last job as at SAC as working for the chairman of the board on as a proposal advisor. And so I spun off my own company to do both systems engineering and proposal development because the two actually were pretty well tied together. And that was my first book, in fact, was called Proposal Engineering, which was applying systems engineering techniques to proposal development. And very successful in that area. But over time, we started growing the company, and we started adding young people, and they can't handle that proposal feast or famine cycle. So more and more over time, we gravitated more into doing more contract work. We were using a variety of tools, particularly Vitec Core was our primary tool. But as we got into the mid 2000s, I guess, it started getting to be where we saw these tools just weren't progressing, particularly in the systems engineering versus the software engineering area. The software engineering tools were dramatically changing and improving and gravitating, bringing in new things, new technologies. The systems engineering tools weren't. They were desktop based and very focused on kind of really software related languages and approaches. So back in about 2011, we said, well, what could we do about this? So we did a couple things. One was help develop a new language which was the lifecycle modeling language. And then we decided at that point, we talked to a number of the vendors and they said, well, we'd like to see you implement this language. And they were saying, well, no, we're pretty happy with what we're doing with our proprietary databases and approaches and lack of interoperability and lack of scalability and all these other things. But we said, well, wait a minute, why don't we do something about this? So in 2012, we decided to go ahead and develop Innoslate. I had hired some really good programmers in that interim period. We'd been doing some contract work with programming, but this was something that was very exciting to us as a company and to me personally. And so we've spent a lot of time working with our customers, helping evolve it, looking at for new techniques, new capabilities, and constantly trying to modernize the tool. So what you see today is very different than what we first came out with in 2012. Uh, and we do support a variety of different organizations, heavily defense, because that's my background. I'm very involved in defense, but aerospace, commercial energy, medical, on and on. It's been very interesting seeing the adoption and use in a variety of different places where you might not even expect it. Um, so going back to the challenges we ran into, and still this is pretty much the landscape today with most of the tools that are out there. Um, they're not scalable. They cannot handle large numbers. We were talking to Mike Ruskevich, who was the chief engineer at NASA, and he was going around and giving a brief about that same time, about the 2010, 2011 timeframe. And he was saying that scalability was huge because they had millions of parts, millions of pieces of it, just a single rocket. And so, scalability was a big issue. I'd also worked some large programs like Future Combat Systems for the Army, where we had hundreds of modelers, and that was a big problem. So collaboration was a huge difficulty there. And then yeah, and difficult integrations. So to actually support the entire life cycle, we had to tie together a lot of different tools. So it was just getting to be kind of absurd almost in terms of the integration problem. And then so they tie that together then with cost. And so there's two forms of the cost. One is the software themselves are expensive and need support, upgrade, training. So that gets to be a pretty significant sum of money. I estimate about $30,000 and for per person, per systems engineer, if you really wanted to support them across the whole life cycle, doing all the things we're supposed to be doing in systems engineering. And the Navy actually validated that number for me and said we replace about 30,000 worth of tools. The other is the time it takes to learn the tools and use them and the process that oftentimes you're not using them all the time. And so that going back and relearning and how hard it is to pick it back up and use it when you do need it. So those became big issues too. And then security. Again, as you can see, we were doing very high level national security projects. Um, the foreign ownership of tools is a huge problem in that area. Particularly contractors can't even install many of the tools in their own environments because of that. And then miscommunication, lack of real be able to communicate to all the stakeholders. Systems engineering, that's our job. We're supposed to be the translators between all the engineering disciplines and management and other users and on and on. So we have to be able to communicate with everybody. So we came up with Innoslate as the solution for that problem set. And so looking at the specific things we do, replace many tools. Again, it's about 8 classes of tools that we're replacing. Requirements tools, modeling tools, simulation tools, risk analysis tools, cost analysis. You kind of name it. We do the whole picture. And then we one of the problem with that though is that you have a cognitive overload with tools. They get to be so complex, it gets to be overwhelming. So we've tried to apply particularly in the software design, but also in use of quality AI products and capabilities to help minimize these kinds of problems. And we auto-generate all the diagrams from the data and things like that. So there's a lot of version control, things like that built into it. And of course, one of the things is we provide support, version upgrades, and training are part of the package. It's not, in fact, we provide it frankly for free because we have a free version that we let people use. It's used heavily in academia for free, and we're happy to support everybody because we learn a lot when you say you have a problem with the tool. Security was another big thing for us, as I mentioned earlier. So we actually went through the entire process of getting a secure technical implementation guide from Defense Information Systems Agency at DoD, or DOW now. And so that's kind of a making sure you really are hitting all the things you possibly can hit in terms of security factors. Um, Containerized onto Iron Bank is another thing that's out there. We've actually CAC enabled access. It is 100% developed and owned by the USA in the USA, so there's no foreign ownership issues. Uh, we have a very interesting capability both doing data sharing through role-based and also redaction. So you can actually hide information from people who don't have need to know for that information. And I think that's another unique feature we have actually. ISO 9001 and 27001 certification was just recent. We thought the STIG from DISA was good enough, but apparently not for people. They want to have their specific certification. So we're working through them all to make sure they're there. It's all the same stuff. It's actually almost amusing, except that it's doggone expensive. Anyway, so we are cloud native. That doesn't mean though you have to use a cloud. There's an enterprise version you can put on your client server or frankly on your own laptop if you need to. So it can scale to anywhere. But since it uses a web browser interface, there's no downloading of the software to your client side. Very easy to use. Consistency of the user interface is another thing that comes out of that. Again, that helps simplify that cognitive overload problem. We have tested the scalability to 10 million entities and 500 simultaneous users. So that's pretty enterprise grade. And I'm pretty sure that if you need more than that, the virtualization on the back end is very good these days. Of course, we use a lot of drag and drop, not only in diagrams, but we also have a documents view. So we actually can see things in a document-like form, but it's still data in a database. It just looks kind of like a document. Um, and of course, cloud, as I mentioned, let's see, drag and drop, I mentioned again, and then that standard ontology. That's that's now probably one of the biggest things is we implemented the lifecycle modeling language. And I will say that's a fabulous language for any vendor to pick up and use. It's completely open. It's not proprietary to Spec Innovations at all. I have had personally a lot of involvement with it, but the chair of that committee is a Naval Postgraduate School professor, just recently retired, Navy captain. So, yeah, and a lot of people from a lot of different walks of life have been involved with developing LML. And I have a slide on that here in a minute. And then real-time collaboration. That's a key. How do you know who's working on what when? Can you work on the same thing at the same time? Yes, you can with ours. And then so you're using that same database at exactly the same time. And then customized reports. We have exports to all the Microsoft Office products and imports from almost all of them as well. So, and in fact, in some, I think it's Excel, we have a two-way back and forth you can do very easily. Uh, and of course, integrations. We support the REST API approach, modern software interfaces like that. We have a modular open systems approach architecture. We can show you that. Um, and we there was a INCOSE sponsored a study at George Mason University where they looked at return on investment for particularly MBSE and that pretty much does come back to the tools heavily. And so they looked at the different tool sets in that area and came with us at a 10x higher than our closest competitor. So it's really a real lot of bang for the buck. As I mentioned, LML. LML is a very simple, easy to understand language. It has classic nouns, verbs, adjectives, things you're comfortable seeing and learning and understanding. Um, we have mapped it to all kinds of other languages. In fact, basically, LML provided an ontology for SysML back in 2015. I know SysML v2 is giving us some kind of an ontology. It's still not clear to me it's a systems engineering ontology. It seems to be like it's more diagram focused ontology. So, okay, great, but I'm trying to do systems engineering. I don't just care about diagrams. I care about communicating all the systems engineering information that we need and making sure we're getting that. We've done a lot of things with the relationships to make it easier, and everything's two ways. So you can have traceability, top down, bottom up, middle out. That's of course critical in our minds to having that for systems engineering. And then, of course, we have all the data elements for this SE modernization, if you're hearing about that, something DoD is pushing towards. And of course, you can easily extend it to other, add things you need to do. It was meant to be a kind of an 80% language, so give you your base underlying schema and then extend it very easily as you need to. Also, just few diagram types are mandatory. There's actually four now. There's an ICD I don't show here. But the unique one probably is the action diagram, and I'll show you why that is in a little bit. So Innoslate itself, again, supports the entire life cycle. We actually have a documents view, so you can author all your documentation. Looks like a document, but it's elements of a database. So they're reusable, they're traceable, very easy to manipulate and work with, and view it like a document. We don't think documents are bad, we just think PDFs are bad. Or Word files where you don't have that reusability and easy traceability. Requirements view is a special type of document. It brings in the quality checker. The quality checker uses the INCOSE requirements working group guide for what makes a good quality requirement. And so it scores you against that criteria. We've actually had this for many years before they even had the guide out. We had this capability in the tool. We've updated it recently to the latest version of the guide and made sure everything was matching their rule set. Modeling. So, of course, you have to have the nine SysML diagram models. That's not a big deal um, because there's a lot of ways to view the information. And we actually have 26 diagram and six charts now. And so there's just a lot of ways to use modeling to help you understand, capture information, evaluate the information. So that gives you that more complete way to look at things. So you can look at something if you want to see as a system L activity diagram, no problem. You could see it as an N squared chart, no problem. It's the same information. It's just shown a little different way, or a lot of the same information, I should say. And then, of course, the fact that we have to be able to integrate with other design engineering tools. The design engineering space is robust. There are tremendous tools out there for that. There's no reason for the systems engineering community to try to reinvent any of those wheels. We just need to figure out what's the data that needs to go back and forth between our systems level tools and the design engineering level tools. And I slide on that more in detail in a second. So simulation. So having modeling's great, but without simulation, you have no idea if your models work or not. And that's actually, I think, one of the biggest problems I've seen in the industry. Everybody focuses on MBSE, thinking all they have to do is model. No, if you're not simulating those models, then you don't know if you can't verify and validate the model, let alone create a calibrated model, which is what you ultimately want to do if you're trying to make it a predictive model. You must calibrate it to real world data because we don't even have the physics to understand everything exactly. So that you're going to have to be able to do that in simulation. We have both discrete event and Monte Carlo, and it can work with cost, schedule, and performance factors. So it actually looks at all the key pieces of data you're trying to get to your decision makers to understand what needs to be done and where they can help them make better decisions. We have a test center. So this is where you capture your test cases, the expected result, actual result, status tracking. We've used this on projects, demonstrations, all kinds of things. We call it test center, but it's all the V&V activities can be captured there and work with. And of course, related back to anything else, directly back to your requirements or anything else in the database that's connected. There is another tool that we've spun off called Sopatra. That came out of an NASA STTR, which we did with George Mason University. We actually took some of their research work and implemented it for looking at standard operating procedures, and they had a very unique way of doing that. That actually was the result of a NASA Phase 1 STTR, which is almost unheard of, by the way. But that's what we did. Of course, you can't forget the programmatic aspects or program management itself. It's an important part of what we do. It's an important aspect of systems engineering. And it's also, there's a lot of tight coupling between systems engineering and program management. In fact, I spent my whole afternoon this afternoon working with the SE PM integration working group. I'm a member of that. We're working with PMI to do some things on updating things like the CBOC, and so we're doing a bunch of things there with them. So that's kind of an exciting thing. If you're coming to the IW, please come to the Monday session. I think it's a Monday afternoon session we're going to have with the PMSE integration working group. There's some exciting things going on there. Anyway, so the programmatic side, I want to look at schedule in all kinds of ways. I've got Gantt charts, Kanban boards, timeline diagrams, calendars, lots of different ways to look at time. And I need to be able to track my milestones, make sure I'm hitting and delivering things when I need to. Cost. So cost is an independent variable in the LML. And so you can create cost hierarchy charts. So you can create a cost work breakdown structure, that kind of thing. So as a separate thing, and then associate those costs with whatever elements cause them. And again, you can create a static roll up here in the hierarchy diagram, but use the simulators to create a dynamic roll up of cost. And so you can actually see the impact of cost over time as well in the simulators. Uh, One of the most other things that's important is risk. If you look at all the ilities, by the way, they all are types of risk. And survivability, maintainability, availability, reliability, all those things are really types of risk. And so you want to have a good way to capture your risks. And we do use probability and consequence as the basis for the risk. We have risk matrices, risk burn down charts. You can create risk registers easily in the tool. So again, very easily way to connect your risk together. We even have the ability to actually generate risks from requirements or anything else. So that's using generative AI. But to bring it all together, again, that's a lot of information. That cognitive overload can get to you real fast. So you need some way to summarize the information and present it easily to decision makers and other people who are just in there maybe to do reviews and things like that. So again, we created dashboards for that purpose. And so you can summarize key pieces of information for different people, and different people can have their own views of it. You can have a project level um, views of the data that people want everybody to see, and then you can have your own personal views as well. So, one of the things I mentioned a little bit earlier was this whole idea of integration with design engineering tools. And we've done some research work with the Missile Defense Agency and the Navy and a couple other customers and looked at these design engineering tools and say, well, where should we tie those together with our systems engineering tools? And we recognize that sometimes you do want data to go back and forth, and sometimes you just want to archive the design engineering results and be able to put that into your simulations so you can run faster in real time simulations, which you need to do if you're doing systems level modeling all the way to the mission and campaign levels. Uh, and so that's what we're trying to do. So obviously you're not going to take a finite element analysis tool that runs hours to represent several minutes of an event happening uh, in a mission level tool, right? So that just doesn't make any sense. So again, that's why you see the ANSYS tool suite at the bottom. They're kind of the gold standard of these design engineering tools. So we're an ANSYS partner and worked with them for years, but we realized very quickly that there was no way to just immediately integrate the two, and it didn't really make any sense to do it. But there are ones that do make sense. So I mean, we have like a CAD viewer, and you can use the CAD information there. You can always export a bill of materials and upload the mechanical bill of materials and add it to your software bill of materials and other bills of materials that you have, and then integrate that total package into Innoslate. Um, on the software side, we have two tools we actually use ourselves. And again, they're very representative of the kinds of tools that you can use in the industry in the software world. So GitHub is the software repository we're using that uses Git. And so GitLab, Jira, many others use the same kind of approach. So we have the ability to create requirements in Innoslate, push them to GitHub as issues, because that's what they do is issue tracking. And then as they do their updates, it updates the status in Innoslate. Similarly, the testing tool that we use is Selenium. Now, Selenium is one of these button pushing softwares. So you program it to push buttons, and that interacts through your user interface and actually tests all your code in the whole stack by doing that. And what we've done with that is we have like 11,000 automated tests we run, and for every release we go through. And so we run those tests using Selenium. It updates the status in our test center of that test sheet, so we can kind of simultaneously see when a test runs what's the actual result of the test. So that's a very valuable way to integrate your V&V on the software side. We have had customers use LabVIEW as well to do integration. In fact, I saw a very nice integration that was done with a CubeSat by one of the customers using the LabVIEW as a V&V tool. Another thing that you might want to be able to do is co-simulation. So, the common tools like STK, which does geospatial kind of analysis, and MATLAB Simulink, which gives you all kinds of equation-based uh, capabilities that are very valuable in simulation. Now, those can be then used at the higher levels in a mission to campaign level kind of analysis. And so we did that. Again, that was part of our Missile Defense Agency work. So we brought those two as integration. But since they're desktop tools, we had to create a Java web app to do the interface. And so that's how that works. At the top, we're native with the whole lens because we're browser based. So all you have to do is put on the whole lens and access Innoslate and use it. So that's kind of, if you're into that world, that AR, VR world, that's automatic. Secure generative AI. Now that one was really important to us because we thought generative AI was a very exciting new technology. However, nobody really wants it to phone home, yeah, and have that data. So we have the ability, we have access to OpenAI, which is ChatGPT, and I think we do 5.0 currently. We're always updating it because they change, it seems like every other week. And then a couple others that have that is Microsoft also has OpenAI, but they're approved to IL 5 and 6. And similarly with Ask Sage, I believe they're also IL 5 and 6. And I believe one of those or both of them are heading towards the higher level clearances as well. So there are future things for that. Also, we give you access to local language model, local large language models. There we go, local LLMs. And so you can use those as well. So those are designed to be behind your own firewall and work with that. And I still have a goal someday that we'll be able to do voice translation too. I mean, it certainly is something I've always wanted to be able to do is talk to my software and tell it what to do. I do it with my car now, so I'm kind of excited about doing it with the software at some point in time. But we're not there yet. So we're always looking to the future and trying to figure out what else can we do? What other technology should we be thinking about to add? One of the things that makes that easy to do is because we use a modular open systems approach architecture. It's really important today. It's the modern way to develop software. So the bottom layer is a SQL database. We currently use SQL Server, Microsoft SQL Server, or Postgres are the two we directly support. Uh, and then there's a Java core, which is the software that manages the tables, does schema extensions, things like that that you can do. And then we use those REST APIs that are public and available for everybody to hook into our user interfaces. So Sapatra is a slimmed down version subset of the functionality of Innoslate with some special capabilities for the standard operating procedure analysis. And then Innoslate is that all written in JavaScript. It's all runs in the browser, including the simulators, the discrete event Monte Carlo simulators actually run in the browser. So that's an interesting capability because it allows you to have that interactive with it. So that's helpful. And then again, so one of the things that we did with this, the reason that's important is no customer really wants to be in data lock. They don't want to feel like they're captive to the software, and they shouldn't feel that way. That's really not fair to the users, and unfortunately, that's been standard practice for decades for most software in this field. Um, you have to have ability to migrate your data when you need to migrate your data. So our job is to do as good a job as we can to keep you as a customer because we're giving you new things and new capabilities all the time. That's our philosophy. And speaking of that, well, this was an update we did back last January. It was one of our feature releases. We alternate between feature releases and what we call usability releases. Reusability releases are, bug enhancements that are more minor features, minor problems, fixing something, adding new frameworks, things like that. So we released 4.11 back in January, and you can see all the feature set we got in here, including presentation view, which, by the way, so you probably thought we were in PowerPoint, but we've been in Innoslate the entire time. So I did not do death by PowerPoint. And many of these diagrams and pictures are actually in the tool. So you can actually come over here and I can go see the live diagram here of that diagram that's built into this. So, okay. So that's cool. If I move this, I change this, it'll update automatically that. Another thing, by the way, is you can reuse slides, which was something I always wanted to be able to do in PowerPoint and couldn't do. So this has been fantastic for our training packages where we reuse the same slide decks over and over for different training packages. I'm sure you have your own uses for it. So again, that's a quick overview of InnoSlate. Hopefully, you see the big picture, all the different things of it. Um, I don't know if you have any questions so far. If you do, I think if you can do the chat, and then whoever's mo monitoring it can ask questions, please feel free, or unmute and ask me questions. I'm happy to take questions anytime. And while you're thinking, I'm going to go to another view. So let me go to that.
Yeah, hey Steve, I'm checking to see if there are any questions in the chat.
Okay. Okay. Well, I'll keep going until I hear questions. So how's that? Because I can talk for hours on this subject. So it's my
Uh,
favorite subject.
Yeah,
Good
no.
evening, Dr. Dam. Can you hear me?
Yes, absolutely.
This
Go.
is Mark Adams. I'm in the Science and Technology Directorate at DHS
Mhm.
and also supporting CBP in their work with Innoslate.
Yes,
Um, I've dabbled in it, so this was an excellent overview. I have two questions.
sure.
One, early in the briefing, you showed how how the LCL LML sorry
That's right.
maps to DODAF, UAF, etc. Is that a two-way map? if I have if I have a repository of a life cycle that's done in the DODAF artifacts, all 52 of them. Can
Mhm.
that get into Innoslate easily?
I would not say there's nothing easy about pulling data from one tool to another tool currently
Right. I
because
agree.
because there's no standard ontology everybody's subscribed to. That's the fundamental problem.
I know that's we all hold up our little crosses every time someone says the O word.
Exactly. I know, but it's important because it gives you that
Oh
common
yes. Oh
language to
yes.
yeah. Yeah.
The other it's more kind of projection is we're all now moving into digital engineering,
Mhm.
which is one step past the MBSE. And when you have your life cycle systems engineering V, I look at digital engineering as a flipped up reflection on top. So as you're building your simulations, and then with the ANSYS, the powerful, pseudo environment or virtual environment elements that can bring in, as you get towards the end of the V, you should also be start working on that digital twin that
Mhm.
will connect to your system with two-way communications and hopefully have that speeded up simulation to do just enough ahead prediction to help you. I was part of the interagency working group that we put together a little paper, I don't know what to call it, handbook guide for federal agencies on using digital twins for failure prediction. And
Mhm.
all the time you're giving this briefing, I'm seeing that V upside down, and that's my virtual system as
Yeah.
as you're going through that. And I what I just really asking how do you see when I get close to that end of the V, where Innoslate can help me actually start making those connections to what is either the prototype or pretty near the IOC system.
Yeah, so it really is more at the higher level, looking at the mission and what are you doing and deploying in a bigger scheme of things. Um, the individual digital twins that I see going on, it really tend to be at a system, lower level system kind of level is about all they can get to. particularly given how limiting our understanding is, even of basic physics. I don't know
Mhm.
if you're aware of how nuclear weapons are designed or have been designed actually since the even the 50s.
Sure. Yeah,
Yeah,
they were represented on this working group. We had
yeah,
NASA. We had I forget the acronym for them, the nuclear guys.
yeah,
Um,
yeah. The Nest Nest team.
yeah.
Uh, I was I was a Nest team member.
Okay.
I was actually a designer of a national exercise. Um, and it really is a way to model, but a lot of that's the calibration of the models
Hmm.
and
Right.
understanding the limitation of the models. That's a lot of what often doesn't get really well documented. And that's what a tool like Innoslate can do is help you capture the information about your system. The
Right.
documentation side of it is what's missing. And people keep saying, "Oh, gee, well, we're not doing document based." Well, document based means we're not doing things in PDF and Word and everything in paper ultimately, um,
Sure.
on tracking things that way. So we give you that document like environment with the modeling environment together. And so now you've got the best of both worlds and you can see things as you need to, uh, and be able to abstract things and present it to people. So one of the things we've been able to do, some of our customers have been doing is for some time now, is model-based reviews. So actually, we had one customer doing that for about 7 years now. And some of them have just recently been using the presentation view to do milestone reviews. Um,
Absolutely.
yeah.
That's where CBP is going. We're trying to get rid of our acquisition document forest, and
Yeah.
go because once you print a document, once you make a PowerPoint presentation, they're OBE. So doing essentially, I call it the live briefing. If
And,
all of a sudden some senior executive changes something, you could change it right there at the meeting, and it's there in in your repository to update and they can approve.
and
Uh,
that's
yeah.
and that's one of the future things we're looking at right now. Actually, we're working on another project with MDA where we're looking at this kind of thing of that how can we create probes of the system to bring information back and help us update our models automatically. I mean, things like that. So
Yeah.
there's a
Yeah.
lot of things going on in that area that very exciting to me.
Excellent. Yeah,
So,
and CBP is another place to look because that's where we're
oh,
starting with
great.
that.
We'd love to
Yeah,
help you do that because I think it's very exciting. Your mission is every bit as hard and complex as DoD's, and your budget's just a lot less.
yeah, and our spectrum's a lot wider.
Yeah.
The Coast Guard's pretty close to the Navy, and
Mhm.
they're digitally challenged. Just to be polite, but I mean, when you go all the way over to the Secret Service, who has to protect the Pope when he comes for a
Yep.
visit, and scanning tulips from Holland for aphids, and so
Mhm.
we've got quite a big mission,
Oh,
and
yes.
trying to get all our frontline components to play along. I'm up at headquarters. Um, sometimes I get the 60 nautical mile stare when I start talking digital engineering, and other times I've got folks that jump right in and start buying all these things, all this software and all this stuff. And I
Yeah, and
said,
that's another experience, isn't
yeah,
it? Where
yeah. I said,
you go buy stuff and then
what
expect
about
it magically to work together, and yeah.
yeah, and training and the people they don't even have all the engineers. So
No.
yeah. Uh,
Yeah.
uh, but
Yeah, we
this was excellent. I really appreciate this, and I did a few screen captures. But is there a way to get the slides that you have
Oh,
here?
yes, yes. If you just ask our salespeople, they'll be glad to give this
Ah,
slide.
okay,
That's probably
terrific.
yeah, because
All right.
they have all that stuff and they have it actually prettier than I have it. I was showing you.
Hey, I go
I'm
for
s-
content,
yeah,
quality, yeah, not
yeah,
show.
and I like to keep it up to date and stuff too. So
Terrific.
yeah,
Well, thanks again. I appreciate it.
yeah,
Over.
And I highly recommend, I can walk through the rest of the tool, but I think really probably more importantly is the resources we have for you. So you can go to our website, to our resources page, and there's just a tremendous amount of material here. Uh, Particularly one of the things we just added was an impact analysis on our spider diagram. That's kind of exciting new thing. We've been doing a series on real MBSE. We just updated the book, and so I was supposed to do part three today, but I'd gotten in late from my Hawaii trip, so I couldn't do it today. But we have rescheduled it. There's an ultimate guide to MBSE, white papers, ebooks, all kinds of things here. It is used in the university, so there's a lab manual for the real MBSE book, even all kinds of guides to things, and particularly integrations, um, comparisons between things. This was an interesting comparison because they actually found that it was twice as easy to use Innoslate as some other tool, which was mentioned there. And then there's even a book for kids, by the way. It has been, its tool has actually been used in teaching at the fourth grade level. Um, so it's that kind of range. We've done extremely high fidelity work. I personally worked on a high energy laser test bed where we were creating a digital twin of the test bed. And so we were down at the software message level. So you can get very detailed, but you can also keep it high level and easy enough that kids could use it. So we've got business departments using it, HR departments. It's just kind of amazing to me the different people who found that the tool is usable for their own environments and easy enough to understand and learn.
I
Uh,
wish Innoslate was around in the early 90s when I was using STK for the Army Jitters radio. And
yes,
back then it was called the Satellite Toolkit. So,
yes, yes,
yeah.
yes,
So,
yeah.
so to have the Humvees and the other vehicles that were points of presence, there was a satellite with altitude of 1 Earth radius
Yes, yeah.
and a very slow speed. But I used that as a satellite toolkit.
Yeah, 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 and we have that integration with STK, and it's
Right.
really
I saw the
yeah,
tile as you were
yeah.
scrolling by. Yeah.
And then we've got videos, all kinds of videos. Young
Mm.
folks really like the videos. There's a digital curation station, which is kind of cool. If you go to that, there's all kinds of documents and things that have been already parsed for you. So again,
Wow.
it's the first place to look. And if anybody has stuff that they want to contribute to this, we're always willing to post it here because we think that's what we should be doing too. So there's just a lot of material, and of course there is a whole help center in the tool itself. There's access to the help center right here, and you can do an Innoslate help bot is actually trained. So that's an AI tool trained to our help center. So you can do a natural language requests, things like that. So just lots of things here for that to work with things. And of course, again, that support is here and available to you. Um, and I think you'll find that there's a lot you can do here. Um,
Mhm. My gears are going. So can't wait to get back up to the talk next time I meet with CBP, see what they're up to.
So I think there's a training coming up here, by the way, in next month if we don't get another shutdown. So yeah. So by the way, is there any other questions? Any specific questions, things people wanted to see or hear about or
I have a quick question. This is Alicia Akoff. I'm actually contractor working over at the Dahlgren.
oh yeah.
And how can I describe this? So our situation is we kind of use Innoslate, but we kind of don't. So how do you convince those that don't want to use it or the more modern tools to use it? So, for example, I don't know how do you get software people like those who use GitHub and stuff like that to want to integrate with it?
Yeah, and so again, that we have a very nice integration with GitHub, so that is one way to do it. And have the and if you're a software engineer, you should be using software engineering tools. I have
Yeah.
absolutely no problem with people using GitHub, and we use IntelliJ, Selenium, JUnit, lots of different tools that are out there and available for the software world. Uh, but we haven't had a really good systems engineering tool, to be honest. We were close with some of them, but it just weren't improving, and particularly things like this diagram. So this is an action diagram. That's a very
Mhm.
understandable diagram because I don't have to guess what this means. It's a loop. It's the entrance and exit criteria for the loop. And or, it's one branch or the other. So very simple, simple palettes, not overwhelming for you. But if you want to see it as a SysML diagram, that's not a problem. You just come over here and select the activity diagram, and you can build it as a SysML diagram. And we even include the simulators for it. So you have discrete event and Monte Carlo. Uh, but the problem with this diagram is it doesn't do modeling of resources. The IOs can't be used as variables, which we can use in Innoslate and in a action diagram. And so there's a lot of value in doing those things because you can model greater fidelity, um, and simulate it to determine that you have predictive information. So if I were,
Yeah. Yeah. So yeah, I agree with this. So, but I'm trying to convince the department to use it,
so one
use
of the
something
things,
that's more
yeah,
uh that will replace some of the different tools that we're using because it's all kind of piecemeal. Somebody has this data point, somebody else has that data point that they could,
right,
integrate with, but I want them to all use like one tool. And it's
right.
getting hard to it's really hard to convince them.
Well, and the key is data migration, the ability to migrate the data that you need to do answer the questions you're trying to answer with the tool. So you go back to what questions am I trying to answer? And usually as a systems engineer, I'm trying to optimize cost, schedule, performance, and mitigate risk. Those are my main things I'm supposed to be doing. And
Mhm.
decision makers want to know those things. That's what they're looking for, particularly like cost. This is telling me my cost, my risk of my cost in terms of that spread. You see this distribution here. It could be as little as 200,000 or it could be 1.2 million, 1.4 million. So that can make a big difference in a program if you're doing those kinds of cost estimating. Can't do that. And most of the other tools that I know out there. Uh, Also time. What's my schedule impacts? This process could have taken 5, 6 days, or it could have taken almost 2 months. So again, those are the kinds of things that decision makers are looking for because it helps them understand where the impacts are. If I change something, what's that impact? I can see the analysis quickly, easy to understand, and you can even archive those results as well in as as an artifact in the database. You can archive any piece of information from your design engineering tools, things like that, as well as an artifact in the database. So these are all things that let you do things that you just can't do in the other tools, or simple things like equations. So they have a something they call what's the parametric diagram, right, that they use. Well, we said that's okay, but what I really want to do is see it as an equation. So here's my equations. And then I want to be able to compute with those equations. So we do that. We give you the ability to define variables, and then you define the equation in terms of those variables, and then it'll make the calculation for you. So that's a little easier to understand for most people who are no math, which most of us do. Certainly, this level math is very simple. Um, but these are the kinds of things that again are unique to us that I don't know if there's any equivalency anywhere else. So if they want to do everything the hard way, and what are they getting out of it? That's really the question that needs to be asked. What are you getting out of that tool? Are you getting what you need or not? And I think very often you're not getting the things decision makers really need.
All right. Thank you.
Yeah. There's a very interesting thing going on LinkedIn. Mark V, and I can't ever pronounce his last name right, but he's a good friend from AIAA and NDIA and some other places that we interact. I don't think he's very involved in INCOSE, but he has been involved in these other organizations, and he had a very interesting paper on just talking about these problems. And just like what you're talking about, how do you get people to see the value? And I think that's a lot of what we're trying to do is what's the value of systems engineering? What's the value of model-based systems engineering? And if you can't see it in something in the tool, then that tool isn't helping you do a lot. So any other questions? I know we're getting running low on time. Oh, so I got a question here about asking about the learning. So the learning is very easy again for students. First of all, there's a guided tour you can take. So you just select one of these types of problems you're interested in, and the types of things you're looking for, and it'll walk you through the tool. That's one aspect of it. But I really would suggest go back to our resources page. Look at all these guides that are out here. Go to the YouTube channel, look at the videos, just a lot of things. There's an ultimate guide to MBSE, lots of different things. The books are there and available as well. If you're an old-fashioned person like me who likes to read books and learns from books, that's cool too. You can do it. So yeah, there's just lots of different topics, things you care about. We believe we address them, and if we don't, let us know because we certainly are always looking to do something more and better. So, and we really do listen to our customers.
Hey, Steve, I had a question on the LML, the lifecycle modeling language. You said that's open standard.
Yep.
Who's the standards body that kind
It,
of administers it?
So it's the Life Cycle Modeling Organization, which is a not-for-profit. It's a new organization, so they haven't gotten a full, blessing as a standards organization, but it is a group of people who have gotten together to do that. There is a conference coming up, by the way, in April called EDGE. And if you go to lifecyclemodeling.org, and let's just do that real quick. .org. And there we go. And so you can see more about the organization here. There's resources. You can download the specification. There is actually a digital version of the specification now too. That's the living version. And we're working actually with some standards bodies to do that kind of digital development so you can have a stable URL you could link to instead of having to download and parse a PDF and then have it change and lose all that traceability. So that's something we're working on too. But the Edge conference is here. And you can see this is available. The call for papers is still out and available, I think. Well, the abstracts are due the February 3rd. I wouldn't be, it is not unusual to see that slip a week or two. But that's coming up here pretty quickly. That's right after the international workshop in LA. And it is being supported by INCOSE. They actually have it on their website as one of the conferences that's out there. So again, if you're
Great.
interested in joining the organization too, come to that meeting. You automatically made a member of the organization. It's a membership meeting as well. So
Okay, good. You answered my second question. Is this this standard endorsed by Nkosi? Sounds like the answer is yes. Is that
it's certainly heading in that direction fast, and
okay?
it is the only language that's truly an integrated program management and systems engineering language. It
Mhm.
has both aspects of it. And
Mhm.
that's something I think is unique again in the industry. I don't know any of the other standards that I've seen out there that really cover both and that
Mhm.
connection between them. That's important for us. Well, any
Okay.
other questions? We're out of time, so I know people, it's late, and I know I haven't had dinner yet, so I imagine others are hungry.
Yeah. All right. Do we have any other final questions you want to ask Steve before we close out here?
Hey Jeff, this is Sean.
Okay.
I think there's a comment in the chat. I don't know if you can access.
Yeah, it's about the undergrad. I think, correct me if I'm wrong, Steve, you answered this one already, if I'm not
Yes.
mistaken.
Yeah, I
Okay.
did. Yeah, I
All
hope I
right.
Got
did.
it.
Yeah.
Okay.
Again, and we're happy to, again, if anybody wants to contact me, it's fairly easy to do. I'm on LinkedIn, so please connect there if you want, and happy to help anybody get going and getting started doing good systems engineering, because that's what we want to do. We want to do good systems engineering, and not waste people's time with
So,
modeling for modeling's sake.
yeah, I think the two important letters in NBSC is SE, right? So if
Exactly.
we're not doing SE,
Yeah,
NBSC is useless, right? In my
exactly.
humble opinion.
Exactly. I totally agree with that. And a lot of times I'm seeing is it's model based, it's not systems engineering.
Right.
So let's do good systems engineering, guys.
Right.
Hey Steve,
Using.
this is Sean again. So yeah, thanks again for your time today. I know you had the webinar earlier today too, so thanks for coming back and do this for WMA chapter, and we try to also spread the word with other chapters and student chapter. So good to see some presence, and as Jeff said in the beginning, the chapter plans to do this monthly for this year, and we hope to have a better, audience, and we'll come back with the other solution provider in this space. So look forward to
Mm.
that. And Steve, if you have any availability later this year, we'll also ask you again if you don't mind again. So
Sure. Be
yeah,
happy
so
anytime.
this
It's
is
very,
great.
yeah, very easy for me to do. I do demos constantly for people, so it's not a problem.
Okay, thanks so much.
Yeah,
Over to
Steve,
you,
I'll be
Jeff.
out. Yeah, Steve, I'll be out to IW this weekend, and so I'll be
Oh,
sure to
wonderful.
tag up with you. So
Absolutely. Absolutely.
cool.
Everybody, well, thank you so much and have a great one. And we'll see some of
Yeah.
you at W, if not, hopefully online somewhere else.
All right.
All
Thanks,
right,
Steve.
thank you
Yep,
all.
that concludes our tutorial for this month. Daniel, we'll have our next tutorial is like Sean mentioned next month. We'll have let's see, we'll have model-driven solutions presenting to us their product. So um, without, I guess I'll just if there's no further questions or comments, we'll close out the session. Thanks again, everyone, for attending.
Thank you. Good night.
Good
Good
night.
night.